This has been the dreaded stoichiometry, the word that everybody's like, oh my gosh, it's chemistry. No, don't get scared by stoichiometry. You guys have kind of been doing it and you just didn't realize it. It's just now we're going to take it one step further. But stoichiometry basically is this: how reactants in quantities relate to quantities of products. Now, how do you use this in the real world? My biggest example is this. Hot dogs come in a package of 10. Regular size hot dogs, not bundling. Regular size hot dogs come in packages of 10. And hot dog buns come in packages of 8. Now, if you were trying to make hot dogs for like 700 people and you wanted to spend as little money as possible without any waste, or as little waste as possible, and you wanted to use up as much of the buns and hot dogs that you could find out how many packages of each you needed, and that's stoichiometry. Okay, and then how much money you needed to spend. Like, let's say you only had a certain amount of money, and you knew how much everything was, and you had so much to buy. Okay, so that's kind of how it's used in the real world. You can also kind of think of it like this: if it takes 2 wheels and a frame to make a bicycle, that's a 2 to 1 to 1 ratio. So if you had 17 wheels and you had like 10 frames, how many bicycles would you make? You know, kind of a thing. That's the idea behind the stoichiometry, is taking quantities and how you have these. If I tell you you have so much so much reactant, how much product could you make? That's where it's going to come in handy. So let's jump right in. Okay, so first thing you need to know is we can go from mole to mole, moles to grams, grams to mole, grams to grams, moles to liters, liters to moles, moles to atoms, atoms to liters, etc., etc., etc. I am going to give you guys in class, and you probably already have it because I probably gave it to you before, a foldable. Okay, a foldable. Then I'm going to kind of show you a little bit and hope you can see with all this mess. I need a bigger board. I really need a bigger board. And I'm going to show you how to use this. Okay, on this foldable though, it only has grams, but where you have grams, you can always replace liters. You can replace atoms and things like that for that, whatever you have and whatever you're given. Okay, so you'll have this foldable. You will not be able to use it on a test, but you can use it to practice and get the idea of what the foldable is. Okay, so, or what this, how to work the problems. Okay, so you're going to need to you need to translate and balance equations. So if I give you words, you're going to have to put them into equations, and then you're going to have to balance them. That's why we've been doing so much of it. You're going to have to convert given to moles, convert moles to given to moles of unknown. So convert moles of unknown to whatever you need. So kind of we're going to go with that and work with our foldable. Okay, so that's the idea behind all of this. I have 3 separate problems on here. You have these same problems on your paper. You should have your foldable. So we're going to get started. Okay, so if this video is long, I apologize. We're just going to go with it. Okay, so on your first problem, it says you have 150 grams of oxygen. How many moles of nitrogen monoxide can you make? Okay, so first thing you're going to do is we're going from grams to moles. So on your foldable, the part that says given, you're going to find grams of given, which is, oops, I think I have this upside down. Do I have this upside down? Okay. Yeah, okay. Grams of given. No, I don't have it upside down. I'm just doing it backwards. Grams of given, and it comes from the problem. So this would be your given right here. Okay. So you write that down, and we're going to start with a track, and this number always goes on the top right here. And you write down everything. Okay. So we're going to go from grams of given to the moles of the unknown. Okay, so the moles of unknown. So on your foldable, we're going to go from here to here. Now you notice I color-coded mine. Everything in pink has to do with the given. Everything in blue has to do with the unknown. Okay, so I should have done this in pink, but I'm doing it in blue up here. But anyway, okay. So you already know what's on top goes on the bottom. So we're going to just work with putting grams of oxygen. You notice I haven't put any numbers in, right? So grams of given from the problem. We're going to put 1 mole up here, and then we're going to put our substance because we're using the same substance, O2. Okay. Now where do we go? Well, we have that. We're going to go over here. Now we have our unknown. I'm going to use a different color. I think I can use orange on this one. Okay. So our orange is we have a mole of what our unknown is, our question mark, right, of NO. So what's on the top is going to go on the bottom. Sorry, O2, I forgot that step. Okay, so now we have everything out. Why do we do what's on top, what's on the bottom? Because we need to get rid of it, okay? We need to get rid of it, all right? So what do we do now? Well, I have numbers in everything except for here, here, and here, okay? So I need to put a number here. Well, if I look on my foldable right here, it says PT. We have grams. Grams stands for go to your periodic table and get your molar mass. I need my molar mass of oxygen. So my molar mass from the periodic table is 31.998. Okay? 31.998. I'm running out of boards, but I need a bigger board. Definitely. Okay, so where do we get these numbers from? Well, I'm moving on down my thing here. It says mole coefficient. Mole coefficient. If you remember, what are coefficients? They're coming from a balanced chemical equation. You can add that to your foldable. It comes from the balanced chemical equation. Okay, so where do we find that? Here's our chemical equation, and it has to be balanced. So we are using that. So our mole of NO, there's our coefficient. Okay, and then our other one, we are looking for oxygen, is right here. So we put our 5. Okay. And now we have our stoichiometry set up, okay? So far, so good, right? Okay, I'm gonna go ahead and do this next one, and we'll come back to the math, because I think if we set it up right, and use our foldable, we'll be okay, all right? So we're given 290 grams of aluminum. So you put your 290 grams of aluminum here, okay? And you notice on my foldable, I have a 1. You can put that or not. I just put it there so you know, don't put anything else but a 1 there if you're going to use it, because 1s get canceled out. Okay, so what's on the top, we put on the bottom, grams of aluminum. And we're going to go to liters, okay? And I'll come back to that in just a second, but we're going to have grams of aluminum to liters. So we're going from grams to liters. Well, I can't go here because that only goes to the mole, okay? Oops, wrong way. Okay. Grams to mole, so we have to open it one more time, grams to liter. Where you see a periodic table, you can use one of our conversion factors. We will give these to you on the test. 1 mole equals your periodic table in grams, or it equals 22.4 liters, or it equals 6.02 times 10 to the 23rd, which is Avogadro's number, okay? So just substitute out molar mass for 22.4. So I'll come back to that in just a second. But here we are. We did our given. We've got our grams down here. What goes on top of it? 1 mole of Al. Okay. What's on the top goes on the bottom. And I forgot I shouldn't have put the 1 there yet. Okay. Al. Okay. And then we have what's above that one? The moles of the unknown. So I did that in orange. Moles of Al2O3. We're trying to see if I have this much reactant, how much product can I make, okay? Am I done? Well, no, I got 1 more step. So I'm going to take my thing out 1 more time. And what's on the top, and you notice it's in the same color. So we're going to use the same color. It is moles, and I ran out of room here, A2O3. And then we have up top, well, it should be periodic table molar mass, but we don't want periodic table, we want liters. So remember, the 1 mole is equal to the periodic table, or it can also equal 22.4 liters of Al2O3. Okay, so I'm going to go ahead and put 22.4 in there. I'm sorry, let me scratch it out. 22.4 liters. Okay, now I'm going to plug in my other numbers from here. Okay, I'm gonna put this down. I'm gonna plug in some numbers. Do I know my molar mass for aluminum? And unfortunately, I don't remember it. I don't have my periodic table here, but this would be your molar mass for aluminum. So this comes from the periodic table. Okay, this is a 1. Okay, here is this is the key here. When you have a mole over a mole, you go to your balanced chemical equation and you find your mole ratio. Remember, your mole ratio is your balanced equation. And it's your coefficients. Coefficients. Okay, coefficients. So I'm going to find my coefficient for this one, Al2O3, and put it here. I'm going to find Al, and I'm going to put it here. Okay, the 1 goes here because it came from my foldable, wherever you can see it. Right there. What? Oh, sorry. Wait, where is it? Right there. Right there. Okay. And I have my 22.4. All I needed was my aluminum, and I, for some reason, cannot remember aluminum. But you probably have it, so there you go. You set it up. Okay. On this last one, if we set this up, we're going from moles to atoms. So I'm going to start in the mole, and it goes to moles here, so I have to open it up. Where you have periodic table, remember, 1 mole is equal to the Avogadro's number, which is equal to the periodic table in grams, molar mass in grams, so I can replace molar mass, periodic table, with Avogadro's number for this. So my foldable is opened up 3 spots. I need a 3-track. Okay? I start with what's given, 7.7 moles of H2. What's on the top goes on the bottom, H2. Okay? You look at your foldable. What's up above that? Well, we have a mole to mole, so I need my other one, which would be moles of Au. Okay? What's on the top goes on the bottom, moles of Au. What's on the, what are we going to? Well, we need to go to our question mark, which is atoms of Au. Okay? So now we just plug in numbers. Well, this one's pretty easy because we don't have to find anything on the periodic table. We don't have any grams. So what do? Well, when we have mole to mole, that's your coefficient from your mole to mole ratio. You go back to your your balanced equation, and you find Au. There's Au. Here's hydrogen. Okay. Now, on my foldable, it says right here, where my periodic table would be, that underneath there's a 1. So let's just stick a 1 here. And then atoms, anytime you see atoms, you should think 6.02 times 10 to the 23rd. Atoms. Okay, so now let's go back to how we work these problems. Okay, so I got all these down. They're all worked exactly the same. You got 2 ways you could do it. I don't care which way you do it as long as you get to the right answer. You multiply it across the top, you multiply across the bottom, and then you divide. Or, what I like better is I take every number and I start going 150 divided by this, times this, divided by this, equals. Okay? So, I would put, and I don't have any room here, but it would be, in my calculator, 150 divided by, periodic table, because I can't write, times 4 divided by 5, okay? And then enter. So there's multiple ways you can do it. We'll work the problems in class, but I want to keep this video somewhat short. Just make sure you have everything set up the best you can. What's on top goes on the bottom. What's on top goes on the bottom. Try your foldable out. Okay, so I'm sorry, it goes this way. Mole to mole, easiest one. Okay. Grams to mole. Moles to grams, grams to grams, or you can substitute out anything for grams. It could be either liters or atoms in any of these spots here. Okay, so I'll see you guys in the next video.